Hi, let's solve the third question from today's weekly contest, that is minimum operations to write the letter Y on a grid. In this question, we are simply given a grid, n cross n grid, and we are already told n is going to be odd. And all the elements inside of this grid are going to be 0, 1 or 2. Okay. And now we say that a cell belongs to the letter Y if it belongs to one of the following. Okay, so basically what we are trying to do is, what is written here is that you have to form a structure Y inside of the matrix. Okay, so how do you form this structure Y? You have to take the diagonal starting at the top left cell and ending at the center cell. And take the diagonal starting at the top right cell and ending at the center cell. And take the vertical line starting at the center cell and ending at the bottom border of the grid. And all the cells that you have in this diagonal, and this vertical line, they belong to this structure Y. Okay, so let me show you. So you are given this grid, okay? So see, what I'm told, take the top left diagonal up to the center, this. Okay, this is the center, right? Center cell, you first have to locate the center cell, and as the matrix is odd, there is always going to be a center cell. You don't have to decide what it is. It is only going to be n by 2, right? N by 2, n by 2, right? This is going to be your center cell. Then take the top right diagonal up to the center, and from the center cell go to the bottom of the grid and up to this cell, right? So these cells that lie here, this is the Y structure that is being formed. Okay, and let me highlight the cells to you. It will be much clearer. Okay, this is one cell, this, then this. So I hope now the Y structure is clear to you. You're given this Y structure. Now see, they're telling you that this Y structure is the letter Y only if and only if, right, all values at cells belonging to the Y are equal, right? So every value that's inside, that is a part of this structure, must be the same, right? And all the values not belonging to this structure must also be the same. So all these values that you can see here, right? Let me show you this, right? All these values with green pen that you can see are the values which are not belonging to this Y structure, right? And they must also be the same. Okay, so all the values belonging to the Y must be equal, all the values not belonging to Y must also be equal. And there is also third condition, that the values at cell belonging to the Y structure are different from the values at the cell not belonging to the Y structure. Okay, so basically, let's say your Y is made from 1. Okay, so your Y structure contains value 1. So your um, all the cells which are not included in the Y structure, they must not be 1 at all. Okay, they can either be 2 or 0, because they also have to be same, right? So all of them must be 2 or all of them must be 0. So now I hope you are understanding, right? First of all, you have to look at this Y structure. Then this Y structure is the letter Y if and only if, right, these three conditions are met, right? All the values inside the Y structure, they must be same, and all the values that do not belong to the Y structure, they must also be same. And the third condition is that whatever are the values inside the Y structure, they must not be equal to the values inside of the non Y cells. Okay, so these are the three conditions. Now you need to return minimum number of operations needed to write the letter Y on the grid, given that in one operation you can change the value at any cell to 0, 1 or 2. Correct? Now what you can do is, you can see, you will be given an array, right? And you have to tell the minimum number of operations you have to perform for this Y structure to become this letter Y, right? These three conditions you have to make true. So they can or they cannot be true initially, right? If they are not true, look at this particular test case. You have 1 here, 1 here, 1 here, and 2 here. Now if you can convert it to 1, right, and all these values, these are 0, 0, if you can convert this value and this value to 0, right, here you can see this is 1, 1, 1, 1, 0, 0. Now this is a valid Y structure. Okay, this is a valid Y structure. Why? Because these three conditions have been met. Because for this Y, see, this is the Y, right? So all these values are equal, and all the values which are not Y, they are also equal, and these Y values are not equal to the non-Y values. Correct? So this you have to tell, and you have to tell like what values of cells you have to change here, so that you get this proper Y structure. Now there can be many possible ways, right? But you have to tell that particular way in which the operations are going to be minimum. All right, so let's see. So I hope you've understood the question. Now, if you look at this particular example, right, you can see that you can also see the change that they've done. What they've done is, see, they have made all the y structure values as 0. And they have made, let's take a look, all the non-y values as 2, right? And they've also shown you what values they have changed, right? These, all the values that you can see in blue here, they have changed it, right? And these cells, right, are the cells where they have performed operation. An operation is simple, you can replace them with the value that you want to, right? Among 0, 1, 2, correct? So the number of cells that they have changed are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is going to be the answer in this case. So 12 is the minimum number of operations. Now, so I hope the question is now clear. Now let's look at the approach to solve this question, right? So let's first look at the logic, right? So we already know that this particular matrix is going to contain 0, 1 or 2, right? And one condition is that the number of ones, the cells inside the Y structure, they must be equal, correct? So they can either be 0, 1 or 2, right? This is for Y structure. Similarly, let's say 0 is inside of your Y structure. So your non-equal cell, non-Y structure cell can be 1 or 2. Similarly, for 1, if your Y structures all value are 1, then the number of non-Y that you can have is either 0 or 2. You can either put 0 or 2 there. Similarly, for 2 in non-Y structure, because 2 is inside your Y structure, right? So inside of non-Y structure, what you can have? You can have either 0 or 1 values, correct? Now, you have to check among these possibilities, right? Among these possibilities. Okay. So what we're going to do is, see, in this question, right, as there are only 3 elements, so there will be only these 3 possibilities. These are all the possibilities that we are going to have, right? So if we simply check what are the number of zeros that we have, what are the number of 2, 1 inside of the Y structure and inside of non-Y structure, and we can simply take the minimum out of these 3 possibilities, we will get the answer, correct? So this is the whole logic to solve this problem. You don't have to use any DP or anything, because you're going to have only these number of possibilities, because the number of array elements are limited here, okay? All right, so what we'll do, we will calculate number of okay, so zy represent number of zeros inside the Y structure. So you have to first inside this matrix calculate how many zeros are present. So here you can see there 2. Then check how many ones are present inside the Y structure. So OY represents that 1, 1, 2, right? Then how many 2 are present inside the Y structure? They are 1, 2, 3. All right. Now check the number of zeros, ones and twos inside of the non-Y structure. Okay, so Z and Y is going to be the number of zeros inside of non-Y structure, which is this, right? The green ones. So 1, 2, 3. So there are in total 3 zeros. Then number of ones in non-Y structure. So that is represented O and Y. So there are 1, 2, sorry, this is the, okay, 1, 2, 3, and 4. So there are 4 number of ones that are present inside of non-Y structure. Then number of 2's that are present inside a non-Y structure. So they are 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11. So T and Y, number of 2 in non-Y structure are 11. Now, as I said, you have to consider possibilities. Now let's say, I say that, see, if I fix this T and Y, right, let's say all the values in my non-Y structure, they have to be same, correct? If I take my T and Y, right, as the non-Y structure value, that means I have to change all the ty. So first I have to change this 3 and 4 to 2, correct? I have to change these 0 and 1s to 2, because I am considering that inside of my Y structure, right, this matrix that I'll form, these values will be 2, correct? All these values will be 2, non-Y structure. That means I have to do operation on all the zeros and ones. I have to change them to 2, correct? So I'll add these. So 3 plus 4. So this is the first possibility. Plus, then I know that I have to change all these ty, right, too, because as we know, inside of the non-y structure and y structure, the values cannot be same, right? So if I've already considered that I am going to have 2 inside of the non-y structure, then 2 must not be present inside the y structure. So it can be either zeros or either 1. So what I'll do is first add this t, right? Number of 2 inside of the non-y, inside of the y structure, okay? So it's 3. Plus what you will add? You will add minimum of what? Zy and oy. Why? Because you want minimum number of operations, right? So you can have either 0 or either 1. So what you'll do is to convert all of them to either 0 or 1, right? So you'll take the minimum out of these, right? So that will give you minimum number of operations, correct? So here you, because both of them are same, so you're going to have 2 only. So this is the for the first possibility. So the first possibility is this. Let me draw these possibilities for you, okay? So the possibility is, if I take this matrix, okay, how many we have? 5, right? So I'm saying inside of the y structure, please have first we are only discussing about the non-y structure, okay? So inside of the non-y structure we have only 2. Oh, sorry. Right. So in total we are going to have 6 possibilities, right? If we only place zeros here, right, we can have 0 inside of the y structure, or we can have 1 inside of the y structure, right? So let me draw another matrix. So we are considering 2 only here, okay? And this is also 2, and we can have 1 here, right, inside of the y structure. So these are the 2 possibilities, and we are calculating the minimum here. So we already know that we have these 2's, right, inside of the non-y structure. So I have to remove these zeros and ones, right? I have to convert all the zeros and ones. So number of zeros and number of ones you have to calculate in your answer, correct? All right, so 3 plus 4 you will calculate. This is the first possibility. Now the second possibility is, if I take the non-y structure, so if I take inside of non-y structure 2, okay, then I can have these 2 possibilities. If inside of my non-y structure I'm going to take ones, right, then what will happen? If I take 1 here, right, so I'll be having something like this. All right, and we can have 2 possibilities, right? If the non-y structure I have fixed it to 1, I can have either 0 or 2 instead of the y structure, correct? All right, so now inside of the non-y structure I only have the possibility of having zeros or 2. And if I consider my non-y structure to contain 0, right, if I'm considering inside of my non-y structure zeros, then what will happen? Right, so I'm saying now 0 you are going to have inside of your non-y structure, so like this. So you will be left with the possibility of having inside of the y structure 1 and 2, right? Now, so these are the six possibilities, and for each and every matrix, you're going to have only these six possibilities, right? So all you have to do is fix the non-y structure or y structure, right? And calculate for the other two possibilities, the minimum among the other two possibility. Now, why I've shown you this diagram is to let you understand that, let's say you want to make this, right? For this, what are the number of operations you have to do? For this, what are the number of operations you have to do? So that is simply because you are considering 2 here, right, inside of the non-y structure. So you will not add these two, right, because 2 you're already considered. So you have to add the number of zeros and ones. That will be converting, correct? So add number of zeros and ones. So for this particular case, all you have to do is add z and y plus ONY, that is the number of zeros and ones in the non-Y structure, because you are considering 2 to be inside of the non-Y structure, right? So you have to convert all the zeros and ones to 2. And as you know that 2 is inside of the non-Y structure, so you cannot have 2's inside the Y structure. So you have to add TY as it is. Then you have to check the minimum among, if you convert all zeros to ones or ones to zeros, right? So you have to take minimum of what? ZY and OY, right? So this will give you the minimum among these two possibilities. Then similar thing you have to do for the second case. So if you consider 1 to be inside of your non-Y structure, you have to take, okay, so if you're considering ones, right? So you have to convert all zeros and twos to 1. So take zeros and 2's of the non-Y structure. Now, because you are saying that inside of the non-Y structure, you're going to have 1. That means inside of the Y structure, you cannot have 1. So you have to convert all the Y ones inside of the Y structure. Then you have to calculate among the two possibilities. That is, inside the Y structure, now you can have either 0 or 2. So if you convert zeros to 2, what will happen? And if you convert 2's to 0, what will happen? And among them, what is the minimum? So minimum of what you'll take, zeros of the Y structure and 2's of the Y structure, right? So this is for the second possibility. This is for the first possibility. And the third possibility, you are considering the non-Y structure values to be zeros. That means you have to convert all the 2's and 1's inside of the non-structure, right, to 0. So you have to add, for this the possibility will be ONY plus TNY, right? These you have to convert to 0. Then you have to, since you have taken 0 as the non-Y structure value, you have to convert all the zeros inside of the Y structure, right? So also include OY, number of zeros, oh sorry, ZY, number of zeros in the Y structure, and also calculate the minimum of the two possibilities. That is, if I convert all, sorry, I have taken this as 1, it was supposed to be 2, okay? This is 2, right? So among 2 and 1, right? Which one is the minimum? So you have to take minimum of OY and TY. So among minimum of this and this will be your answer, right? And these are only the 6 possibilities that you are going to have in this particular test case, oh sorry, in this particular question, okay? So among these 3 possibilities you have to check. So the approach is quite easy. Now I hope you're understanding. All you have to do is, first you have to calculate number of zeros, ones and twos inside of the Y structure. Then calculate number of zeros, ones and twos inside of the non-Y structure. Then simply check for these minimum of these 3 possibilities, or rather 6, because you are also considering this, right? So in total 6 possibilities. So let's quickly go ahead and see the code. So what we are doing, first we are taking these variables zy, oy, ty, zny, ony, tny. So zy, oy, ty representing the number of zeros, ones and twos inside of the Y structure. Zny, ony, tny representing the number of zeros, ones and twos inside of the non-Y structure. Then I am also taking this visited. This is basically to mark the um, cells inside of the Y structure that we have already visited, right? So first, what we are doing is, we are simply taking the diagonal, which is from the top right, oh sorry, top left to the center, right? So center I know is going to be n by 2 only, right? And up to the center you have to take I comma I. So you know the diagonal is going to be 0 comma 0, cell is going to be there in the diagonal. 1 comma 1 is going to be the 2 comma 2 is going to be inside of the diagonal. So you, this is only one iteration that you have to do. Okay, so instead of, you're just reducing the time complexity, right? You don't have to write big O of n square, rather you have to simply write this, because you already know that I and I are going to be the same. Calculate, so this is for this part, right? So we are calculating for this, the number of zeros and ones and twos. Okay, then we are calculating for this part, number of zeros, ones and twos. Then here, so see, so here again, you know that I is going to be there, and these are also same, right? So if this is I, sorry, this is I comma n minus I comma 1, so you'll get this particular cell, right? Similarly, you will get this particular cell and this particular cell. So this is what you have to do. So you'll check for these. Then you will check for that vertical line. So it starts from n by 2, goes up to n. So you know n by 2 is the column number, right? So it is the same, the column is same. It's just the rows that are varying, and rows are starting from n by 2 cell. Correct. So you calculate the number of zeros, ones and twos inside of this vertical line. So after you have done, so you're done for the y structure. Now I have marked this visited I comma I and this, so that when I have to mark for non-zero structures, right? So I will simply do a traversal inside of the grid, and I will simply check if the cell is not visited. Only then, right? So visited cell belong to the Y structure. Then I will mark number of zeros, ones and twos inside of the non-Y structure. Then, as I said, you have to take the minimum of 6 possibilities. So first possibility is this. So I'm considering first, in the first possibility, that your non Y structure is having twos, right? So you have to convert all zeros and ones, and also take the number of twos inside of the Y structure, because you're already taking it inside of the non Y structure. So you have to convert all those twos inside of the Y structure, then calculate minimum of the ones and zeros, right? And similarly, if you take non Y structure values to be 1, and if you take non-y structure values to be 0, so these are the 6 possibilities, and among them the minimum you have to return. So this is basically how you had to solve this question. Now discussing about the time and space complexity for this question, you can already see that the time complexity is going to be big O of n square, right? So it's big O of n, big O of n, big O of n plus n square, right? Then space complexity is because of this visited array, right? You can also get rid of this by simply checking for this condition, but you will have to write these conditions. So just to avoid the confusion, I had taken the visited array. But yeah, so for this particular approach, that what I have done, in the space complexity will be big of n square also. But if you do not use this and simply use conditions, right? That if I is equal to, like if I is equal to j here, and also check if I is equal to n minus I minus 1 here, and if j is equal to n by 2, right? And I is greater than n by 2. So these three conditions you can check and get rid of this visited array. So then your space complexity will be constant, right? So this is basically how you had to solve this question.